Good morning, everybody. Let's get started. Glad you're all tuned in here, ready to learn about the things that we need to today from Algebra 2. We're going to talk today about roots and radical expressions. Please remember, feel free to pause as many times as you need. Take notes. Keep yourself going with these things. Give yourself a chance to think. Make sure that you pause often so that you can think before hearing actual answers. We're going to start today looking at a little bit more into roots and radical expressions. You are familiar with square roots. Square root of 25 is 5 is nothing different for you guys. Knowing that 5 is the square root of 25 comes from the idea that 5 squared equals 25 is where we jump off on this thing today. Notice that sometimes there are little numbers in these radical signs. These little numbers tell us which root you're actually talking about. A square root has an implied 2 in here. When we have a cube root, when you have a little 3 here, it's saying what number times itself times itself. In other words, 5 times 5 times 5 gives you 125, which makes 5 the cube root of 125. It comes from 5 cubed. Once again, there's a 4 in the radical sign, and so we would call that the fourth root of 625 equals 5, because 5 times 5 times 5 times 5 equals 625. 5 to the fourth equals 625. Same thing here. When you've got an index, we'll call this an index, the number that's in the radical sign. It tells you how many times you're looking for a specific number to multiply together to give you this number. So 5 times 5 times 5 times 5 times 5 gives you 3,125. So 5 is the fifth root of 3,125. Once again, I encourage you all the way throughout, if that only is on the edge of your understanding, to pause and replay that part. All right, I used this word index a second ago. An index is the number that is in underneath of the radical sign. If there's no number here, it's implied to be a 2 for a square root, which is what you're used to. Index, radical sign, radicand is the number that you are taking the root of. There are certain rules that we need to think about as far as what the numbers are in here. So if n happens to be odd, if n is an odd number, then there is just one nth root of the number. For example, if we're looking for the cube root of negative 27, negative 3 times negative 3 times negative 3 would give you negative 27. There's just one value for that. But remember, when we would look for something like the square root of 9, that could be either 3 or it could be negative 3. So we can use that to talk about the idea that if n is even and a is positive, there are two nth roots. There's a positive one that's called the principal root, and there's a negative one that is the negative root. And once again, if a happens to be negative, in other words, the number under the radical sign, remember we tried to take a square root of a negative 4. We got an imaginary number. Well, we're just looking for the real answers right now. So the real answer would be that there's nothing. We're just going to consider it no real solutions if you have an even root, because you won't be able to find any numbers that multiply times themselves to give you a negative number underneath. So the odd ones always will have one root. If a is positive and n is even, you'll get two nth roots. And if it's negative, you're just going to say that there's no real roots. So let's look at some examples here. So we need to find the cube root of negative 8. I'll give you a second to think. You're thinking what number times itself is going to give you negative 8. And so the number that actually fits and works in that would be negative 2, because negative 2 times negative 2 would give you negative 4, or positive 4. And then multiply that one times negative 2 again, and you end up with negative 8. So your answer here would be negative 2. So think it through for a minute and ask yourself the question, like for a square root, what number times itself? And for a fourth root, what number times itself is going to give you that number underneath? It would be a good idea to pause here for a second before I do a reveal and talk about that. Now, if you thought it through, you might have thought it was 0.02 or 0.2, but you can always go back and multiply and just double check to see if this works. I'm going to pull up a paint here. As you know, sometimes it doesn't really quite work right with that, but if we do 0.2 times 0.2, we'll end up with 0.04. Move the decimal point 2 places, so 0.04 for that. So you can always go back and double check. If in your mind it had struck you that it might have been 0.02, let's look and see what 0.02 would have given us. That would have given us 4, but you'd move the decimal place 1, 2, 3, 4 places. And that would not have given you the original radicand. So since it doesn't give you the original radicand, that would not have been the solution to that. There is no real root for the fourth root of negative 1, because no matter how many times you multiply a negative times a negative, if you do that 4 times, you're going to just get a positive number, so no real root here. And here's an interesting thing, because you have a negative under here and you have to square it first. That would give you 4, and with no symbol in front, we're looking for the principal square root or the positive square root. So the square root of negative 2 squared would give you just a regular 2. It would not get, you could think about the negative square root as being the second answer, especially if they said give all the roots. But with no symbol here and no instructions, you would just be looking for the regular number 2. Now that brings us to this idea of there sometimes being a number that you have to square root, you have to take the absolute value of to get the answer, like something like our negative 2 that we just talked about. So let's think for a minute. If A is an unknown number and you have an odd index, for example 3 or 5 or 7, we aren't really going to do 7, but just if you had an odd index, what we find here is that, for example, the fifth root of negative 2 to the fifth power, the fifth root undoes the fifth power, and we would get a negative 2 here. There's no need to multiply that out, because you already know that you have that number times itself 5 times, so our answer is negative 2. The thing that gets different in that is that if you have an even root, in other words an even index, like 2, 4, 6, and then you're trying to take that root of this number to a power, you need to take the absolute value of whatever this number is. So the absolute value of negative 2 would give you positive 2. Because you can imagine when you multiply this out, negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 would be positive 16. So the fourth root of positive 16 would give you a regular 2 as long as there's nothing out front of it that tells you that you want the negative square root. Okay, let that sink in for a minute. When you're simplifying, think about the number part as being separate from the variable part. Okay, there's a little note down here. This is going to make sense in a second. But if we really think about what this means, okay, this is 9 and then 8x's out the back of it, and we're taking a square root. You can look for pairs in your variables. So every time there is one pair, one of these x's comes out. So in other words, the square root of x squared would be x. The square root of x squared would be x. So there would be 1, 2, 3, 4 x's come out. And then you would consider the square root of 9 also, which would give you 3x to the 4th. That leads us to our little shortcut here, is that if you have an exponent and you have an index, remember the implied index here is 2 for a square root, all you have to do is take the exponent divided by the index, and that will give you the new exponent for that variable. 9, remember, is 3 squared. So 2 divided by 2 would give you a 1, which gives you your 3 right here. So it's a nice little shortcut, and this is why it works. So let's think about this one for a minute. We want the cube root. Cube root 3 is our index. Here are our exponents. So think for a minute. If you take the exponent divided by the index, it's going to give you your new exponent. So 6 divided by 3 gives you 2, so we get an a squared. 9 divided by 3 gives you a 3, so you have b cubed. And there that is happening. So when you are used to doing this, when you've practiced a little bit on your assignment, this is going to become more natural to you. You're going to be taking the exponent divided by the index, and that'll give you your new exponents. When you have an odd index, it's much easier. You don't have to think about that little technicality where you've got any absolute value bars involved at all. It's the fact that we've got variables in here that means when we have an even index, for example, a 2 or a 4 or a 6, we need to be careful about thinking through whether or not we need absolute value bars or not. We still use the rule where you take the exponent divided by the index. So here when I take 8 divided by 4 and I get 2, that gives me an x squared part of my answer. Now, let's think this through for a minute. Whether x is positive or negative, and we don't know, it's a variable, that's what a variable means. But if we have that, whether it's positive or negative, and square it, it's going to automatically give us a positive, so we don't have to think about any means of turning that answer into a positive. However, when you take this 12 and divide it by this 4, that would give you 3, but when you are thinking about the y cubed, if y was a positive number, then cubing it would keep it positive. But if y were a negative number, then it would turn it into a negative when you cubed it. But we want the principal square root, in other words, the positive square root here. So if we cube it, and since we don't know if it's a positive or negative, the last little technical step would be to put absolute value bars around anything if you used an even root, an even index, and you ended up with an odd power. Okay? When you have an even index and it ends up giving you an odd power, put the absolute value bars around it. That applies for variables only, and it only becomes an issue with what I was talking about a second ago. Sorry about that with this. Okay. Now, fractions. I know that some people don't necessarily love fractions, but fractions do not have to be horrible. When you take a square root of a fraction, just think about it as the square root of the numerator divided by the square root of the denominator. So square root of 1 is 1, square root of 9 is 3, and you're thinking of it as two different problems. If you happen to have an even root, okay, if the directions say to find all of the real roots, don't forget that you have a positive and a negative, just like we did when we were solving our roots in the last chapter when you were trying to find the answers. Maybe you were solving by completing the square or some other method. Remember, we had two answers. So if it says to find all of the roots, don't neglect the second root, the negative version of it, because 1/3 times 1/3 gives you 1/9, but also negative 1/3 times negative 1/3 gives you 1/9. So this can apply to fractions, it can apply to decimals. You can always write a decimal as a fraction to help yourself out. So when you're looking for the cube root of 125, remember the odd indexes, the odd roots, are going to be a little bit easier because you're only expecting one answer. So when you're thinking about this one, you're taking the cube root of 125, for example, the cube root of 1 over 125. What number times itself times itself? 1 times 1 times 1 gives you 1, so 1 in the numerator. 5 times 5 times 5 gives you 125, so 5 in the denominator, so you end up with 1/5 for that one. Back to here. You see 81 and it's a fourth root, so you think about what numbers begin to go into 81, but it's not just 81. Remember, it is 0.0081. So when you start thinking about what numbers multiply or what numbers might be multiplied 4 times to get 4, probably one of the first numbers that comes to mind is a 3. Okay, if you wanted to, you could put 81 over 10,000, but it's really not going to help you. But think about this 3. Start thinking about, well, what if I took 0.3 times 0.3? That will give me 0.09. And then if I multiply that times 0.3, I'm going to get 27.027. And then if I do that number times 0.3, there's where my 81 comes from. Move it 4 decimal places. And we end up with the right answer. So our answer to this problem would be 0.3. If it asked for all of the roots, you would have 0.3 or negative 0.3. So I want you to think for just a quick minute and think what number would give you the answer for the cube root of negative 0.027. So let's pause for a second, and you pause and go ahead and figure that out. All right, now hopefully you got negative 0.3. I'd like to talk for a second just about the homework expectations. Remember, you're doing these homework assignments for you so that you can understand better. This is a whole different way of educating and learning, and so you are important. You have an assignment, assignment number 74. If you go on your grade link and click on the assignment and the details, it tells you what problem numbers are required, and it gives you do at least. So do at least a certain number of questions, problems on that assignment. And then you can consider it done. However, since you're striving to do your very best, there are some problems even beyond what I would consider the minimum to do for that are also listed when you check into that assignment. So you need to make sure that you're doing your best. All right. When you have completed that assignment and you log in tomorrow and you look at your instructions, you'll see that there's a form, a Google Docs form to actually submit your homework assignment. And you would click on that, you would answer a few questions. Now I do plan as the time unfolds to possibly change up the questions a little bit, and so you should always have your homework assignment in front of you when you're answering these questions, because the more honest and upfront you are with the questions, the better I can help you and answer whatever might be difficult for you. So please make sure that when you fill out that Google Docs form, there's a place where you can explain the things that were difficult for you or the things you still need help with. And then I can produce another video to help you to understand certain things. So those of you who are accustomed to raising your hand and asking questions, keep on doing that. Do it through the Google Docs, though that'll be the most efficient way for me to gather up your questions. My email inbox is going to get super full if everybody's sending them, and it's a little harder to organize. So if you want to, you can still email me your questions, but understand that in that daily turning in of the homework, if you will, it will be giving you opportunity to tell me which ones that I need to go over. So please be diligent in filling those out, and just kind of do your best. And I expect you to do your best. Do your best for you. And I miss you all. I would very much rather be in front of you right now and getting your feedback and looking at your faces and going around and helping you, but I'm still here for you. So God bless you. Have a fantastic day, and we'll see you when we see you. Bye.